So I'm sharing with you, can you see my screen? Can you see the Git and GitHub
Yes.
slide? Yep. Thank you. Awesome. Evan, Anna. All right, Git and GitHub. So you've all had, so I guess Rohit and I have targeted this toward those of you that are fairly new in the lab, but also those of you who've been around a little bit could probably gain something from this too. You've had a little bit of an intro to Git, and some of you are actually using Git. And so the first few slides will reiterate some of the intro stuff with a little bit more underlying concepts, and then we'll go into some command line activities, and Rohit will guide you in a guided activity using command line for some more advanced stuff. So this slide set I'll share with you. We're not actually going to watch these videos because there's a real nice little intro video here, but it's like the basic idea of why do you want to do code versioning. And this girl is talking about how if you make a tractor and then you get an idea to make a better tractor, you can use code versioning to sort of test your version of the better tractor, share it with other people, let them try it. If they like it, somebody else can contribute something else to your tractor. And it's kind of a cute analogy. Just to make sure you are all fully aware of the difference between Git and GitHub. And by the way, it's not get. In Utah, we tend to blur get, and we say get is Git. This is one thing you can actually call Git. It is Git. Git is the code versioning software itself, whereas GitHub happens to be one commercial website that's useful that basically runs a Git server. You could stand up your own Git server tonight if you want to. You could use any number of other Git servers, like Bitbucket or GitLab or SourceForge runs Git. In fact, in China, GitHub is not allowed. So they have other code versioning commercial companies, but they are running Git. In fact, Git has become so popular, I don't know if you know this part, but for years and years and years, I used Subversion, and I used a system made by Microsoft called CodePlex, and we hosted so much code on CodePlex. Microsoft was a late but ambitious supporter of open source, so they stood up this software system called CodePlex. Anybody could drop open source in there, and you could do code versioning and everything, and they had their own kind of code versioning called Team. Well, they used Subversion, but they also had this other thing called like Team something. And in time, what happened was the programmers at Microsoft who were building CodePlex started hosting their own code in GitHub and on Git servers. And it became a little bit of a problem internally at Microsoft. They weren't using their own stuff. As David Tarbott, my colleague at Utah State, always says, you need to be willing to eat your own dog food. They were not eating their own dog food. They were using Git instead. And so finally, Microsoft had the wit about them to shut down CodePlex completely and to provide a conversion path for everybody to move their stuff to GitHub. It's kind of fun. Little background. And so think about Microsoft, the 1,000-pound, 10,000-pound gorilla in the room saying, okay, we give up. We'll shut down our stuff and just use GitHub also. So hopefully you all have Git itself installed on your computers. I use it at the command line on my Mac because it's so easy. I love being able to open and use Git directly. It's a little bit trickier to use inside of a Windows command terminal, but you can do it. And then you can also do it at Linux and Unix command lines. And of course, you all need to have, and I assume you all have an account on GitHub. So let me stop right there, and by show of hands, who account on GitHub? Okay, so I see a couple of you do not have an account on GitHub. And so you'll need to rectify that. Anna Cecil, I still can't see your hand or face or anything, but I'm going to assume that you raised your hand. That everybody else, I saw most hands go up except for this guy. Who's in the top right there? Oh, is that Justin?
She raised her hand virtually, Dan. I saw her blue hand go up.
Wow. Okay. Good. Anna is being. Okay. The need for version control. This is another cute little video if you want to watch it. Again, I'll share this PowerPoint. But this guy writes a poem and then he versions it, and then I love this picture though here at the beginning where he's like, this is how we normally do stuff. You know, you have a folder and it's like version 1, version 2, final version, final revised, final really revised version 2, right? This is how you store stuff on your folder. And it's terrible because, I mean, what really, I hate it. You students, if any of you are working with me, never give me a paper that's called final draft, because there's never a final draft. It's going to go through so many more. It doesn't have to have the name final in it. So what he's going to talk about here is how we use version control to alleviate this problem, where you have one version, you version control it on something like GitHub, and then it keeps track of all of the changes for you. And then you can always have access to the last version, but you may not know this, you guys, but you can actually have access to any of the intermediate versions too. You can pull them right off GitHub. That's kind of cool. Okay, I don't mean to play that. Hold on, it's trying to play it. It's trying to play it, I don't mean to play it. Go back to big. All right, so what is Git and GitHub? A system that tracks your changes and allows for collaborative development. You've kind of got that figured out by now. It also allows you to know who made what changes and when did they make them. Years ago, I had an open source project that we had shared the subversion control access a little too widely and let too many people be contributors. And one day we came in and my map window software was completely broken. And it turns out that somebody had uploaded a lot of inappropriate and explicit content into our software. And so we were able to do two things. One, we found out who did it and blocked them. And two, we were able to revert to a prior version with literally just a click of a button and get rid of all of that. So that was pretty nice. And which allows you to revert changes and go back to a previous state. All right, so does anybody know who this guy is? If you do not know who that guy is by his face, raise your hand. If you do not know who he is, raise your hand. Okay, that's okay. This guy's probably one of the most influential computer programmers of the 20th/21st centuries. His name is Linus Torvalds. In Finnish, it would be Linus Torvalds. And he was the inventor, developer, creator of Linux operating system. When he was a young college student, he took a class on operating systems. And they were teaching him how to make operating systems and how operating systems work. And he got this funny idea. He said, what if I could write an operating system in Windows that runs in a DOS environment on a Intel processor chip, but that basically acts like Unix. And Unix was the major mainframe system. So all those big mainframe computer systems of the 70s and 80s, especially the 80s and 90s that sat in rooms, they were all running flavors of Unix. And he wanted to have that same programming capability and coding sort of command line stuff, but have it on Windows. So he invented Linux. And Linux wasn't originally named after himself, but it was named like Micro Unix for a micro PC running Unix. But some of his friends pushed, after it got more popular, they were like, no, we need a better name for this. So they told him to call it Linux after himself. So Linux was developed by Mr. Linus Torvalds, and it became the first major open source operating system adopted worldwide. It runs a huge percentage of the internet. Last I read, it was between 30 and 40% of the internet is run on Linux computers developed by this guy. Completely open source. He still made a ton of money off of it, mostly through his consulting. Linus Torvalds, he needed a new project. And so in part of this century, he sat down and decided he wanted to create something new, realized that the biggest hole was in code versioning, and he developed Git. It was the need for a free open source version control system that was fast for Linux developers. Okay, April 2005, he develops it. Here's some of the goals: speed, bang, support for nonlinear development. You can program, I can program, she can program, we can merge our code in a nonlinear fashion, fully distributed, everybody's working separately. We've all got a copy of the code locally. We've all got the entire version history locally, which is a new cool thing that he did. And then, but we can also cross collaborate and share with each other with our code. Should be able to handle very large projects and be cool. It's not the only version control system out there. Hopefully you've learned by now, and this should reiterate what you learned last week, that there are some other ones Subversion was a huge one. Team Foundation, this was Microsoft's Team Foundation server. Mercurial was one of the first distributed versioning systems where everybody gets a complete copy of the code repo on their own computer. And we tried Mercurial for a while. It was a little confusing. Git came along and was sort of quickly adopted as the most widely and easily used. This is Linus guy. It turns out he's a bit of a jerk. He is an antagonist. He might be a bit of a racist and a homophobe. He's got a really bad temper. But he's brilliant, and it's really hard to argue with the sheer brilliance, the fact that he was able to develop Linux and then Git. And I understand he's been in counseling, so. Let's see, I don't know if you guys saw a picture of like this last week. Does this kind of a picture look familiar? By show of head nodding or confused looks? Maybe a little familiar, not too much. The original version of version control was like this. You had a master repo sitting in somebody's computer on a server, and everybody got a working copy, worked on it, and pushed their results back to the repository. The god of this repository owned it and controlled it and managed it. And they often called that person a benevolent dictator because they were benevolent in that they allowed people to have access to the repo, but they were still the dictator because they could control everything that comes in and out of it. In this mode, this is Subversion, this is Team Foundation server, this is CVS. This worked for years and years and years, but this is the distributed version system that Git and Mercurial uses. In this version, everybody has a complete copy of the repository. I have it, Alma has it, Geo has it, everybody has it. And so I'm committing updates from my repository locally all day long as I'm coding. Bada boom, this is me typing, and I'm committing. And it's all going into my repository on my machine. And Alma's sitting over here and she's committing to her repository on her machine. We may be working on the same bit of code, the same poem, the same whatever it is, but we're doing it completely independently. And over here, Geo is working on his version of the repository. It could be the same repository, but it's his version of it. And then at the end of the day, I go, man, I did a whole bunch of work. I want to get this into the main repository, a centralized server. I don't have to, but I want to put it in a centralized server. I push it to that repository and I pull in the morning from that repository and then work all day again. This is how distributed code versioning usually works. Note that Linus invented it in such a way that you could actually push from here to here. I don't know if you can see my arrow, my cursor, but you can push between my repository directly to Alma's, or Alma can push directly to Geo's, or Geo can pull, I can pull from Geo's into mine. But that's a little inconvenient. And so normally what we do is we have a centralized one that we're all pushing in. Now what happens if GitHub collapses, if there's an earthquake and the servers all go down? Oh, by the way, GitHub was ultimately by Microsoft. That's kind of interesting, little side note there. I think that's right. Rohit, right? Yes, GitHub was purchased by Microsoft for some billions of dollars.
Unfortunately, yeah.
Boo.
Dan, what happens if you and Alma change the same code?
Yeah, so that is a
possible,
really...
or is there security that doesn't let that happen? Because who decides whose change was better?
So that's the question that you all should be asking, right? You should be wondering, because I said that I'm working on it, she's working on it, and Geo's working on it. So I push, and then she pushes, and then he pushes. Well, part of the cleverness of Git is that it does have some analytical tools inside it, and it will analyze the commits that I push. And based on a set of basic rules having to do with which part of the code I'm in and how close my block of code is to the code Alma is working on, it will determine whether or not there's a conflict there. And if there's a conflict, the last person to push will get a notification saying, yeah, there's a conflict, and it'll ask you to resolve the conflict. So if I push, then Alma tries pushing. She might have to go in and resolve those conflicts for her push.
Question.
Yes, sir.
what's the purpose of a local repository? I mean, why not use what's the difference between a working copy and a repository, I guess?
Sure, the working copy, if you think about it, that's the code that's actually, when you open, say, your code editor, that you're looking at the working copy. If you open a file and look at that file, you're looking at your, the repository is now this database on your computer of every change got this point of this file that we're looking at. And so it turns out, again, part of the glory of Git is that's a super efficient database structure where it just caches the incremental changes. So it's not doing multiple copies of the file. It's just doing incremental changes to the file. So the advantage of having it is so that for speed, I'm sitting time I need, I'm just doing it locally to my own computer. I'm not having to wait for network response. The other one is this issue of what if the network goes down? I have complete access to mess around with my repository, back up to an old version, see what I did 3 weeks ago that I forgot, that I lost, pull it back up until I bring in those changes into my current version. I can do all of that locally until I'm happy and then push it to the central repo.
Gotcha.
Yeah. And then of course, the third part is just the ability to commit to each other, because really the distributed version control should show arrows going this way and this way also, because you literally can just be fully distributed, not have any central owner. It's a little less efficient. Good questions. Anybody else have a question? This figure? If you understand this figure, if you can kind of lock this into your brain, then all of the command lines that Rohit will show you will make more sense, because when you're staging something, you're staging it here, kind of in between you and the local repository. When you're committing it into your local repository. When you are adding it, you're adding it to the list of files that are being managed in this local repository. When you are pushing, you're getting out of your repo into some other repo, and when you're pulling, you're coming out of. That's why, honestly, 10 years ago, this was the first thing that caused me so much grief, was just why commit and update versus push and pull. But this figure should help clarify that to you, why there's two different sets of actions. This is another figure that's effectively the same thing, but it's saying that computer A checks out a file. Here's the central control system, and it's got version 1, 2, and 3. Computer A checks it out. Computer B checks it out, and then computer A checks it in, and computer B checks it in. This is the centralized version. And here's the distributed version, where computer A checks out a file from his or her own repo, and then puts it back into his or her own repo, and then can also push and pull it to a central repo. And I like this one just because of this additional arrow. It shows you can push and pull to each other. So let me talk about this slide, and then I'll turn it over to Rohit. So this is the snapshots concept. And in this slide here, we're talking about a file being pulled. But the question is, where is that coming from? Which version, 1, 2, or 3? And what all is contained in that file? That's the snapshot. The snapshot is a current view of the repository. So it's more than one file. It's all the files of your repository snagged at a point in time. That's the way to think of it. So a snapshot. And the camera is to remind you of that. This is the way Git keeps track of your code history, and it records what all the files look like at a given point. Now you get to decide when to take a snapshot by doing a commit or a pull or a push. And because you make these snapshots, you have the ability to go back in time. So how do we know there's a, like looking back here, how do we know there's a version 1, 2, or 3? It's because somebody at some point did something to create that snapshot or that snapshot or that snapshot. So when you create that snapshot, it's a commit. And it's when you're committing to your code, you're saying, okay, I've done all this editing right now, let's commit this in. And the whole system locally will take a snapshot of it. And your project is a series of all of these commits. And every time you commit, one thing that is interesting about Git is it requires you have to type in a little message about what changed in that commit. So when you're committing in the command line, Rohit will show you it's, or maybe you've already done it, it's git space commit space -m for the message, and then in quotes, I updated the retrieval method for the API. I updated line 35. I added a few comments. And so that little bit of information, that message gets stored with the commit. The other thing that gets stored with the commit is an identifier, a hashtag identifier, like this one. And that's like a real hash identifier right there for a commit. And it represents a unique identifier that refers to this snapshot of the code. Now in the database underneath it, the database is storing the incremental changes to your code. And so that database needs a way to know what incremental changes go with it. And so the database uses and says, associate this hash identifier with all of these incremental changes in the code. And then another one. You can make as many commits as you want. It won't fill up your computer if you make more commits. Any more than anything else does. It's not like every time you commit, it's not like making a complete copy of everything. Okay, so I think that I was going to go over the key concepts, repo. We talked about this. We can, so when we clone, that's the act of taking everything out of the central repository or somebody else's repository. I could clone Gio's repository into mine. I can, once I've cloned it, that sets it up in my computer, and then I can pull updates and I can push updates. Mind that those are separate from the commits. And okay, this is the part where I'm going to turn it over to Rohit. So he'll talk a little bit about this idea of kind of branching and pulling off a version of the code and working on it and then putting it back in, and then he'll have you do some command line stuff. So take it away, Rohit.
Thank you. Let's see, share screen.
Oh, let me stop sharing. There you go.
Okay, bring this back here. Okay, so we were here, right? Just talked about repo. So like I said earlier, a lot of what we'll see today is things you have seen before, but maybe not completely gone into a lot more depth about what exactly is happening there. So one of the concepts that I wanted to touch upon was branches. And so Git has, by default, a branch called the master branch where all your files are working. And what branches basically do is allow you to work in your code in parallel. So if you have a piece of code that you want to make 3 different changes to, it's kind of like running a simulation test, just with changing parameters each time. And so each branch can start from the same point. So it can have the same original code, but then you can add new features to each branch. And this really helps when, let's say, 4 people are working on the same exact application, and one of them is responsible for making the buttons look nice. The other one is responsible for the backend stuff with the GIS processing, and maybe someone else is responsible for the styling or the JavaScript portion of it. And so now there are 3 different separate areas of concern in your app, but your app code is the same repository on GitHub. So how do we go about making those changes? Is what we do is we have that common base right here and we branch out from it. Now this is continuing as the master branch, and what this means is basically that there could still be some changes that are common to the entire app that are being done on the main branch, but you're off in this own section of the branch that you started from this point in history. And so you basically go ahead, make some changes to your branch. Let's say you create that new button that you wanted to add to your app. And now what you would do is you do something called a merge, and we'll go over these concepts again, and we'll actually do a hands-on exercise to basically make sure that we understand what branches and merging is. But that's basically is what is happening is there's a master branch, you create a feature branch is usually what it's called. You add a new feature. So each one of these circles is a commit. So you add a couple commits or 3 commits, and then you're like, okay, this looks good. I want to bring it back and combine it with everything else that has been done on this app. And so you do a merge. So this place is where a merge would happen, and a new commit is created that has a snapshot of both things. And again, we'll go over how the merge snapshot is created. And so that could be a little bit advanced, but I feel like it's good to know what is exactly happening inside, because a lot of programmers, when merge shows up in Git or conflict shows up in Git, they just are like, well, we did something wrong and we can't fix this, which is not true. Every conflict, every merge can be resolved. So we just need to work through it in the right fashion. So anyways, allows for a parallel development, safe and separate environment to try your changes out. So this is another good point for using branches, is you're not sure whether your change will work or not. So you just branch out, test your changes on that, and then put it back in if it works. Otherwise, you can delete the branch and try something else. Your main branch of the code is always known as master. So just as an example, this is let's just look at this guy. So we have a GitHub tutorial branch on BYU Hydro-Informatics, which I'll ask you to pull down in a couple seconds. But if you notice, by default, if you just go to this repo, it will always show you the branches master. You can switch to new branches, and we can create a new branch, and we'll do some of that in the hands-on exercise. But by default, every repository will always have a master branch, whether it's on GitHub, whether it's locally on your computer. Even if I just go to and create a new repository on my command line, and I say git init, it says, okay, I initialized a new empty Git repository. And now if I say git status, it's like, oh, wait, I have this bunch of these files, but what I want you to see is it will say that I'm on branch master. So a master branch will always exist in your repository. Okay, guess that doesn't work. Okay, so let's go back to our slides and see what's happening there. Okay, so we looked at this diagram yesterday, the last time this lecture was given a little bit. So just to do a refresher, you have your working directory, which is the directory on your system that contains all the code. You have basically Git looking into the working directory at all times and figuring out if any changes have been made. So all the unmodified or modified files stay in this working directory. Then when you make a change, you stage a file. Again, we'll go through this process in the hands-on, so it'll make maybe a little bit more sense. There are commands that you use to do that, and we'll go over those commands as well. And once they're staged, they're basically, the changes are ready to be taken a picture of. So it's like you've gone into a photo studio, dressed up, and you're ready to take a picture at this point. So your files are ready, we know what changes Git has made, and then you go through them, you go through the changes, you're like, okay, yeah, I like these changes, great. So at that point, we want to take a snapshot, we do a commit, and the committed files are sitting in your Git, stay in your same working directory, but in your local repository. And then we can do a push and a pull, and again, we'll go over that in our hands-on. Just one more slide before we actually go to our hands-on.
What does staging do? I'm not sure I've ever fully understand the necessity of the staging thing.
So staging is a very good review process. So imagine this, where you have a piece of code that you ran a shell script on to rename all the files, let's say, because of some reason you wanted to rename a file, all the files to some extension. And at that point, let's say you make all the changes, but how do you know what changes you've done? I mean, you could do a git diff and see what changes you've made to each file. So I guess there are no changes in this one, but if I just go to yeah, so git diff gives you, okay, each file and each line, this is what has been changed. However, if you just wanted to see a list of files that have been changed, and only select, let's say, 2 or 3 files. So let's say I wanted to do, actually, yeah, git status. So that will give me the list of files that have been changed, but I only want to commit the changes to these files and not the others. And there are a couple options of doing that. One way is I only stage the selected files. So I would say I only want the change in helpers.py. So I say git add. And that way I can kind of, it's like, for me personally, it's more of a verification before I actually make the commit, that these are the files that are being changed. This is the file that is going to be committed. So right now, if I do a commit, these changes won't be added to my commit. Only this one specific file would be. So personally, I think that's the biggest reason for staging for me. I have not found any other purpose. I don't know, Dr. Ames, do you have anything to add? Yeah, that's, I mean,
Yeah,
I
no,
agree that.
I don't know why we have to stage, but I haven't quite figured that out.
Yeah, it's yeah, it's something that could have been lived without. Like, it's not critical, but I feel like sometimes having this ability to do this. Otherwise, what you would have to do is basically you would have to stash all the rest of the files away, all the changes, and then just commit the one that you want.
Okay, well, that makes sense, I guess.
Oh, that wasn't supposed to be done. Well, that's fine.
So in other
So,
words, it
yeah.
allows you to selectively pick which parts you're gonna update to your repo.
Yeah. I just restored about a day worth of work, which is fun. It's okay. We'll do it again. So yeah, be careful while using git restore commands. They will restore your changes back to its original state, which is so weird. I thought git checkout did that. Anyways, so let's go back to this. So yeah, we just went over this working directory staging Git. Keep this figure in mind, and this was the one that I really want to get up on, is this green line right here is our master branch. And as you can see, it's going forward in time from right to left. Each green block is a commit object. So each time you make a commit, it's the snapshot. It's what is being saved is all those changes. And each one of them, if you notice, has this random set of letters and numbers. And this is what is called a SHA-1 hash. We don't have to go into details of what that means, but basically, it's a long string of encoded text, out of which one of the components of the encoded text is a timestamp of when this actually happened. So each snapshot within its name knows when it happened in time, when that snapshot was taken. So in this branch, we have 1, 2, 3, 4, 5 commits. And actually, I think it's going this way from left to right because the master branch is over here. The head is over here. And at every point in time, the head points to a certain commit, which was the last commit done in the repository, in that branch. So the head will always point to that. Now, this just shows that this is another branch that was created when we were at this state in time. So this branch is behind the master branch, as we can see over here. And yeah, that's basically it. So remember that stage will contain the files that will go in the next commit, while the working directory contains the files that you see. And then once you do the commit, they're basically added on to this branch. And we'll look at this diagram again, where it shows how actually a new commit is created and it's added on to the repo. So let's get started on this. All of what I've been doing is going to be in command line. So if you're on a Mac, you're good to go, or on a Linux machine. If you're on Windows, you could use the Git shell, which comes with, which can be installed on Windows, or you could use the online shell at cocalc.com. So if you just went to, let me actually just verify that this has Git. Which I think it does, but yeah. So cocalc.com would be where you would follow if you would like to do this on a Windows machine. Is anybody on a Windows machine? Like, raise your hand. One person. Okay, so yeah, try CoCalc. I think you've used it before, right, Annalise? Yeah. So try if it has Git. I'm trying to sign. Don't want to sign in. I don't know when this will start. So if one of your CoCalc is running, could you just type Git on it and see if something shows up, or it says that the package Git wasn't found? If that is the case, we can find another place where this will work. For the rest of you who don't, who have GitHub on their terminals, we'll just open up a terminal, go to a directory where you're comfortable working in, which is fine if it just opens in your desktop. Is this font size okay, or do you want me to make it bigger? Does it look fine? Bigger, smaller, it's good? Okay. And the first few things that we are going to do is actually, oh, that's interesting. How am I going to share my screen and my slides? Let's hide the. It's okay. Actually, we'll just hop back and forth, I guess. So the first commands that I want you to actually run is, if you've not done this before, this is something that you should do on your system if you've not used Git on the command line before. But what I want you to do is just run, let's use this one, git config list. And yeah, you should see something like these two fields in there, user.name and user.email. How many of you actually have that in your git config? None? Oh, one. Okay, great. Okay, so what we're going to do is basically set these identifiers so that anytime you make a commit, the Git software knows who is actually making the commit. And usually this will happen once you use Git quite a bit and they'll ask you for these things. So what I want you to do is just run these commands. So we're going to run git config global, and we're going to set user.name to whatever your username is. So I prefer using my full name for that so that people can identify my commits. And that's kind of how you would just set it. We're going to do the same thing for, and at any point you feel like I'm going too fast, too slow, whatever, just raise your hand or, you know, use one of those Zoom buttons, I guess. And then we're going to set an email. I'm going to just do my BYU address, which is the same one that I had. And now if I do git config list, I can see that they were already set to the same thing. So that wouldn't make a difference. But by this time, if you guys do git config list on yours, you should see your username and email set up. Are we good on that? Yeah. A little nod would be great.
Actually, how about a show of hands for who is not caught up? I need a second.
Okay.
Lee, Sergio, Travis, let's give them a second to get caught up here a little bit. Do you have any questions while we're waiting for them to get caught up?
I have a
And
question.
Michael, how far are you from Hart?
What's that?
How far are you from Hart?
we're at least 6 feet apart. The camera kind of skews the.
Okay.
So what's the advantage of having a new branch as opposed to just keeping everything on your local repository until you finish your test?
So that's a good point. But what if let's say the changes that you make break the code in a way that it's too hard to recover, even locally. So let's say you change like 15 files and you thought that you were going in the right direction, but then it turns out at times that things just don't work, right? And so now you have to get back to the state that you were. So unless you made a commit on each time that you made a change, it will be pretty difficult to go back to that. That's one reason. The other reason is, what if you yourself are working on two separate improvements to the same application? So if you take HydroViewer, for example, and if I was working on a map component, which is in the JavaScript file, as well as I was making a change to the backend where I was changing the API paths or the database connection or something like that. But the idea is they both are mutually exclusive. So the changes for one shouldn't be with the changes for the other unless we are sure that both the changes work separately on their own. Does that make sense?
Yeah, that makes sense.
Because if you made both the changes in the same master repo on your local branch, you wouldn't know what part of the change caused the problem. So it might take a while for you to go and navigate to the exact issue and be like, oh, it was because of this change that I was making, rather than having it. It's like kind of like separation of concerns. So you don't have a single point of failure.
I have a working example from just a year ago that you guys might find interesting. I was working on a large project with in a consulting mode with a group out of, I don't know where they're, Atlanta or something. Anyway, it was an EPA related project, and there were about 4 programmers working on the project. And so what they would do is there would be an issue posted to the issue tracker saying, we need to fix this part of the GIS map. And so that issue would be assigned to me, and it has the issue number, issue 381. And so I would start a new branch. I would branch the entire code base and call it issue, or I'd call it 381-fix the broken map. And then I had the whole entire code base in a separate branch away from anything anybody else is doing. I could work on it. At the end of the day, I would probably push my results back up to the central server on the branch, knowing I'm not messing around with their code at all, because it was going to take me a week to fix this. But I didn't want it only sitting on my computer just for safety concerns. So I could push my branch to the central server and keep updating my branch, issue 381, fix the map, keep pushing until I finally had it working. And then the cool thing was I would contact the main developer and say, okay, pull in branch 381 and test it. So he would pull it, test it, make sure it worked the way it wants. And then once it works right, he would then merge it, as Rohit was showing, kind of merge it back into the main code base. So it's a way to extract out that problem, really hammer on it without messing around with anybody else, but still be able to store it in the main. He could check my branch anytime he wanted to, or the other programmers could, and then merge it back in. And then the nice thing then too is we've got this numbering system. The issue was associated with the branch. When we commit the branch, and pull it, we can close the issue and say, yeah, this branch fixed it, blah, blah, blah. So branching is pretty powerful that way in a team environment.
Yep.
Hey, Rohit.
And sorry, yeah, go ahead.
Sorry, I missed the last couple instructions as I was logging into my remote desktop. So what exactly are we doing? Could I see your terminal?
Yeah, so we're just running these 2 commands right now.
Oh, okay, this right here. Okay. Oh,
yeah.
Got it.
So
okay.
Just to set your global config so that we have the right name and email whenever we make a commit.
Gotcha. Okay.
What I was also going to add is whatever Dr. Ames just described the process of making a branch, and that's how we actually make commits to bigger projects in the world. I'm going to go through an example if we have time at the end to show you a change that I'm actually submitting to Tethys itself to make a change to the core code, because I feel like that's a good change and they also agree on that. And it's a 1-line change. So we'll go through that process hopefully in the last 2 or 3 minutes, where I'll just run through that. But is anybody at a place where they don't have the git config set? No, we're good to go. Okay, awesome. So now what we're going to do is basically create a copy of the training repository that we have created for this. And the way to do that is using the git clone command and the URL of the repository. Or if you don't already have a GitHub repository set up, you can use git init to start a new repository in any directory that you like. So I've shown you examples of both, and I'm not going to have you do these 2 steps. We're just going to go to the third one. But just to show an example, if I have, yeah, I do have a test git directory, which I've thought I already CD test. Okay. So now this directory is empty. As you can see, there's no .git folder in here. So that tells us that it's not a Git directory. Another way to know that if it's a Git directory or not is just do a Git status on it. And it will do this. Now, the reason this is happening is because for some reason, my main Git directory has become a Git repository, which shouldn't happen, as you can see over here. So I'm gonna get rid of that guy. Don't do this unless you actually want to get rid of a repository, because that's where all the changes are tracked and information for your repository is stored. So now we're going to go into test, and I'm going to do a git status, and it should say it's not a Git repository. So great, we can just say git init, and it'll say, great, I have a new repository here. And then if I do a git status, it'll say, okay, yes, I do have a repository, no commits yet, nothing to commit. Note that this repository has only been created on your local system and not on GitHub, not on your GitHub account, because we haven't done a push yet. So let's not worry about this one. Let's go back to our tutorial. And if we just go to our next slide, there is a link right here that I'm going to paste in our chat window as well, so that it's easier to copy. The UI is really weird. Okay, so here's the link for the repo. And what I want you to do is go to this page. It might ask you to log into your GitHub account. So we're going to go to our tutorial page and click on this button called fork. And we'll talk about what a fork is in a second. You can see that this already has 7 forks, but we're going to create a new one. And I already have one, otherwise I would create a new one. Actually, I'll just go ahead and get rid of it. So let's delete this one. Okay, and so now if I go back to that link, okay, perfect. Yeah, just hit fork. It'll ask you if you have other apps, it will ask you, but usually, yeah. So you just select your username, GitHub tutorial, and now what you have done is basically created a copy of the entire repository from the BYU-Hydro-Informatics repo to your own personal GitHub account. And what this allows you to do is basically work on this piece of code and make as many changes as you like, commits, delete branches, do whatever you want to this code, because you have the permission to do that. However, on BYU-Hydro-Informatics, you might not have the permission to change the actual repo. So basically, we just create a fork, and now whatever is there is a URL. So if you click on clone and you click on this button right here, which basically copies it to your clipboard, there's this URL to your repo. And we want to copy that. So just click this button, go to wherever we are working on, do a git clone and that URL. And what this is going to do is going to pull down a copy of your private GitHub tutorial repository. So I already have it, so I'm going to go get rid of it. And then let's do that. So you should see something like this, cloning into GitHub tutorial. This will happen. Are we all at this point, or do we have any issues? Does anybody have a problem where they're stuck or need some more time?
Who's not there? Who's not following along and they're okay with the fact they're not following along?
I think I'm a little behind. I'm kind of like toggling back and forth.
Okay, so have you created a fork for your repo yet?
I don't think so.
Okay,
I
so
have GitHub up, and I
okay.
pasted. Let's see.
So you go to that URL that was in the
chat.
Yeah, and then hit fork, like right on top right.
Okay, let's see.
So the weird thing is I can tell how many of you have followed along by just seeing how many forks have been created.
Let's see. If can you copy and paste, like if I'm using Google Remote Desktop, if I copy something on my main desktop, can I paste it into?
Oh, I see the issue there.
Yeah, that's the issue. I probably should have logged in through this
yeah, that's fine.
remote desktop, but
Here I would just recommend try typing this URL in, because to be honest, it's not that tricky. Yeah, just type the URL in directly and that should work.
Okay.
Okay, while you do that, actually, I'm gonna just wait a minute more and hopefully you can get the fork going. Everybody else has been able to git clone and they have a copy of the repository on their local machine, right? No issues there? No? Did we have a problem there, Denisa?
My very slow, and I'm working in a virtual machine and in my machine, and I can't.
Oh, okay.
So
that's fine.
So
I'm okay.
go ahead. Is that the git clone HTTPS GitHub rfun GitHub tutorial? Is that what I'm getting?
No, so you're getting a copy of your own fork. So when you clicked on the GitHub tutorial and created a fork, that would have taken you to your personal repo. So in your case, it's probably
GeosGym.
GeoSim. Okay, yeah. Oh, GeosGym. Nice. But yeah, so you'll have a copy here, and then you'll have a URL right here.
How do I see the URL?
So the clone or download button that's in green, if you just click on that,
okay,
it will bring up the URL, and you can just click on this copy clipboard button to have it copied to your clipboard. So you don't have to actually select it and copy it.
All right.
And then in your command line, you can just do git clone command V, and that should be there. So this would be yours specifically. Okay, you there, Travis?
Yeah.
You have your fork?
No, not quite. Sorry, it's
okay.
I'm like keep toggling back and forth.
Sorry, this session might extend a little bit longer than expected. Did anybody have to leave exactly at 2? Okay.
Okay, here we go. Clone it.
So you cloned your fork, right?
I'm cloning it right now. Let me see.
Okay.
I just got the. Okay.
What is your GitHub username?
I think it's TJ Tyler, I think.
So you haven't created a fork. I think you're just cloning the actual one.
Oh, okay.
Yeah, so just when you go, oh wait, actually, let's see. Yeah, I don't think you've created a fork. So just hit this fork button on top left.
Sorry, let me, okay. I'm sorry, where is it?
So I'm sorry, on top right, there's a button called
there
fork.
it is. Okay.
Yeah. Just click on that and that will create a new fork in your personal repo. And then we can go from there.
Fork, there it is. Okay.
Yep.
Okay, fork.
There we go. Okay, yeah, so just clone that one using git clone and whatever is the URL of the repo. Okay. And to get the URL of the repo, what you need to do is just go to your repo and click on clone and then do the copy from here. Okay, so we're gonna move to the next step as there's not a lot of command line stuff, so we should just get through this pretty quickly. So what we're going to do is create a new file in here. And what I basically want you to do is go through the process of adding the file. So there's a command in the command line that's called touch that you can use to create a new file. You could do this using Notepad. You could do this using any other editor app. But basically, we were at a step where we had done the git clone, and now we need to go into that directory. So we'll do cd GitHub tutorial, and I'm just going to do an ls to show that there is no text files in here. There's only a license and a readme file. Great. You should all have those files on your local system as well. And then we're going to do touch test.txt. And what this command is going to do is just create an empty text file called test. That's it. And as soon as you do that, if you do an ls, you can see that that file has been created. We can do a cat, if you remember that command from our CLI training, to see what's inside the file, and it will be empty, which is good because that's how it's supposed to be. And right now, if I do a git status, it says that, okay, great, you're on branch master. Your branch is up to date with origin master. So this is what is telling me that there is a branch, there's a copy of my repo on GitHub as well. And then there is a new untracked file. So which means that any changes you make to this file right now, GitHub is not actually counting those changes. So we want GitHub to actually start tracking changes on this file. So we say git add, and you can see the command over here as well, git add test.txt. And again, you can use autocomplete for this. So you can do TES and then just press tab on your keyboard and it'll fill in the rest of it. It's super useful to use the tab all the time. So do git add and then git status one more time. And this time you'll see there is a change to be committed and there's a new file that it has recognized called test.txt. Everybody here? Do we need a few more seconds or is there any issues that we're stuck at?
The best way to ask that is, who's not caught up?
Yeah, who's not caught up?
Who's not caught up, raise your hand. And then you can do my other favorite method, which is, Annalise, how's that working for you?
It wasn't working well. I was messaging Rohit. I think using CoCalc and Git isn't, I think I need to buy a subscription from when I was looking online. Yeah. So I was like, I'm just an avid watcher for now.
Because you're on Windows. That's like I was saying in the beginning. And just none of this stuff works as well on Windows, darn it.
Yeah.
Sergio, is this verifying stuff you already knew?
Copy.
With Rohit. I create a new file, test.txt.
You feel confident?
Yeah. Yeah.
All right. Go ahead, Rohit.
I have a question.
Uh-huh.
How can I erase a repository? Because I cloned the one, but then when I try to clone the fork, it says that
I see.
With the same name.
So you can just do rm-rf and the name of the folder. So, or you can just do wherever you are in your command line, just do open. So like, for example, you would have cloned it right here. If you do open and look for that directory, so like over here, it's called GitHub tutorial, right? Just go ahead and delete that and that's good. Yeah, you could do it via the command line or you could do it via the UI, whichever method you prefer.
So when you do git add, what does this do? Does it add it to your staging area or?
Yeah, so it's actually doing a couple things. Right now, it's only adding the change that there is a new file that I've created that it needs to start tracking. It is not actually tracking yet what changes I make in that file. But if I had made changes to the file, those would be just considered as the initial file at this point. And from the commit point onwards, it would start tracking the changes.
But what does it have to do with like the repo and the staging, or is it I'm just trying to visualize all this.
So this is right now, you could say that if we go back to here, we had our working directory, we created a new file, and now it's in the staging area. It's a staged file at this point.
So by doing git add text.txt, it adds a staging area?
Yeah. Another thing to see right now is, so if I go ahead and make some changes to the file, so I'm just adding some text to this file, and then I do a git status. If you notice, the staging is still at the same point that it was. It's going to, if I do a commit right now, it's still going to add that empty file that was there. And while the change that I just made is not staged, so I can have some changes that are still, that I have still made in my working directory, but I haven't added it here. So that's kind of like the difference, I guess, between the current working directory and the staging area at this point. Sorry, staging is a little bit confusing at times. And so most of the time the way I think of it is, okay, I look through my changes, do a git stage and do a git commit. Most of the time there's not a huge delay between git stage and git commit. Okay, so let's go back, and I'm going to just do git restore. So we're at this point where we have a new file, and if you do a git status, you should see there is a new file and that has to be committed. So let's move on and basically do a commit. And to do that, we'll type this command, git commit -m. -m is the flag that allows a message. And you can name message. Remember always that the message should be within quotes, especially if you're using spaces in your message. And if I just do this, what it has done is it has created a new commit that starts with these letters and numbers on the master branch and has this message, initial commit. It also tells us how many files were changed, how many lines were inserted or deleted. Since that file was empty, because I undid my changes, there was 0 changes in terms of lines, and it just created a new file. That's kind of what it'll tell you. So basically what I want to do is focus on this diagram again. What happened is we had our working directory, we had a file there, we moved it to stage, and then we said, take that change and add it to our master branch. So our master branch head was somewhere here, which is the latest state of our master branch. And then, so after we made this commit, it took everything it had over here, combined it with the change we made, and made a new commit right here. And that's kind of how the branch works in the background of things. Does this make sense, what happens when a git commit is run? Any questions about git commit? Nope. Okay, awesome. So since you've done the commit, you should be able to let's see, yeah, we should be able to do a git status on here, and you'll see your branch master is behind, and we'll do push and pull in a second, but there are no changes to commit because there are no new changes. So what I want you to do is open your file, and you can do this in a number of ways. You can use a text editor in your terminal, or you could use Sublime or Atom or whatever you use, or text edit. We can just do open this, and this is going to open our folder, and then I'm just going to open this with text edit just to be very general. Then let's make a change. You could type in whatever you want on your file, and let's close that. And after that, if you go back to your terminal and run git status, you should see there is a change that is not staged, which what I want you to see is different from what it said earlier when it was not tracking its file, that it said untracked file. But now it's saying, okay, we are tracking this file and there is a change, but it's not ready, it's not staged yet. You can see the change in your command line itself by doing a git diff. DIFF stands for difference. And what it'll do is it'll show you, okay, this is the file And these are the changes: that there was a plus, which means there's a new line added, it's in green. There is a red, that means this text was removed. And then this is the change. So that's kind of what it gives you the difference of what changes have been made. If you do not like the changes, actually, yeah. So let's look at this and then add this. So we are going to do git add. When you do an add, you can do a couple of things. You can do git add dot. What this does is basically takes any changes in your current working directory and adds it to the staging area. Or you can just do git add the specific file names, the list of files that you want to add. In this case, I want to add test.txt, so I'm just going to do that. Do another git status. I can see now that the change is changed to be committed. Let's say you get here and you feel like you don't really want to commit this. At that point, you can do git reset. And what this does is changes the file back, actually removes it from the staging area. It will not undo your changes. However, there is a way to do that as well, and we'll do that in the next step. But right now, since we have this file already staged, we need to first undo the staging. So we do git reset, and head is saying, okay, reset it back to the current state. Head is the current state of your repo. And then whatever file name. If you did this with a dot, again, it will do it for every file that was changed in your directory. So git reset head, and you'll get this message saying unstaged changes after reset. You have a test.txt that was modified. So let's go back into git status. And at that point, you can see, okay, this change, we're back to our original state where we had a change, but we have not yet committed it. What if we want to undo that change? What if we want to, so right now, if I open this file, I can see there is this text in there. What if I don't want it? Yeah, you can do that. So you can say git checkout, and be careful while using this command, because this will bring it back to the previous snapshot that you had taken, to the previous commit that you had. So you can do git checkout dot again, which will do it for the entire directory and subdirectories actually. Or you can do git checkout with just a specific file. And it says, okay, updated one path from the index. So basically changed one file back to the way it was. And how do we see that? Well, let's do git status, and it says, well, nothing to commit. There are no changes. I don't see any file that has been changed. And if we go back to a test.txt, it should be empty. So that's kind of how you stage your changes and then unstage your changes, and also restore your changes before doing a commit. If you've already done a commit, you can also go back, but that's a whole different deal. And I don't think we have that in these slides right now, but when you do get to use that, it's pretty straightforward. Okay. So everybody good with git reset, git checkout? Any issues there? Any questions? Were you able to follow along how I went through? Yeah. Okay. I'm just going to move on right now to branches. We're going to do a couple branches real quick just to show you how branches are created and how differences in branches happen. So in your GitHub tutorial command line, what I want you to do is run git branch. And you can do experimental, you can call it whatever you want. And that actually, yeah. So what this did is create a new branch called experimental. And now if you do git branch, it'll show you a list of branches that you have on your local repository. Remember, this is all happening on your local machine. We haven't done a push yet. So if I go back to my GitHub repo, I don't see that experimental branch over here, and neither should you. So let's do git branch experimental first. And then you can verify that by the git branch. If you notice, the current branch is highlighted by an asterisk. After that, what we're going to do is we're going to switch to the new branch. So before you make any changes to a different branch than the one that you're currently on, you need to go there. You need to tell your Git that, hey, any change I make from this point onwards in time should be recorded for this specific branch and not for my master branch or whatever branch I'm on. So we're going to switch our branches. And the way to do that is git checkout and then the branch name. Once you do that, you'll see git checkout experimental. And it'll say switch to branch experimental. Again, you can verify that we are on the experimental branch by just doing git branch or a git status, and it'll say on branch experimental again. Now, just to show you how branches work, you don't have to follow along in this part as I might be going a little bit faster, but let's create a new file in this branch. So I'm just going to create a file called temp.txt. And now when I do git status, it shows me, okay, there's a new branch called temp.txt. Great. It also contains that test.txt file that we had added on the master branch because we started from there. So we're gonna do git add. Once that happens, then we're gonna do a git commit. Added another file, and then I'm going to do a git push. So the first time you push a new branch that you've created locally, you will get this message on your command line. Just copy this command and run that. Basically what this is doing is that your remote GitHub doesn't know that this new branch exists. And this command will tell it that, hey, I am pushing something up that is a new branch. So again, when I do a git push, it's taking all the changes from this experimental branch and pushing it up. Now I want to do that for my master branch as well. So I'm gonna go git checkout master and do a git push. And since master already existed on the server, it's not gonna ask you to run that command, and it's not gonna have you recreate the master branch. So just to show you the difference between branches, now I have my master branch. I have this file test.txt, which is empty because I put it as empty. But I also have a branch called experimental, and it has my extra file, the temp.txt that I had added. So it's the same code base, except they have different files. And this is super useful is when you're working on different branches, you're working on different features, and you want to work without worrying about each change causing an issue with the other change.
Go
okay.
ahead.
Yeah.
What's the difference between a branch and a fork?
So a branch is the same code base, just different histories for your same code base, while a repo is a copy of all the branches and all the code that you had. So when you do a fork, you're copying a repo. So it copies all the branches, the entire history, everything, and creates a brand new copy that's not connected to the original code in any way. While a branch, everything is forking from the same branch, so from the same master point. So that's why branches are within a repo, while forks copy entire repos.
Gotcha. Thank you.
So the one last thing is about merging. We've looked at pushing and pulling. It's pretty straightforward. We've looked at this last time as well, is when you have local changes, you want to push them up, you do a git push. You can do a git pull as well. There are two other parameters that you can specify in there that just tell it where to push to. And I'm not going to go into too much details on that. But what I really want to touch upon is merge really quick, just to, actually, we're already way beyond our time. I feel like we should do another session for merge and pull requests and like doing a example of walking through a Tethys pull request maybe.
You know, that wouldn't be a bad idea. And maybe what we could do is let some time pass and let everybody have a chance to try using Git for their own personal projects or for their work they're doing with the lab. And then hopefully, then when we do more advanced topics on branches and merging, there will be a context, more of a context.
Or the other suggestion I was thinking of is I could just record a video about merging and the pull requests and how we would make an actual pull request to a running production application like Tethys. And then if we have any questions, we can set up one-on-one time and work through those issues. that sound good? Okay, so we did some command line stuff. We basically went over branches and merging, but if there was one thing you can take away from today, I would say it's this diagram. If you understand this, you would not have a lot of trouble in GitHub. If it takes a while to get used to it and understand what each component means, but yeah, once you get there, we're pretty good. And you'll hopefully use Git on a daily basis. It's super fun, super useful. And yeah, any questions on what we've done so far today? Any concerns that you're having with your local GitHub workflows?
Oh, Rohit, I see you've got this information in a presentation. Is it linked to the document for the training so that those that are putting things online can do that? Or
yeah, Dr. Ames sent this out yesterday to everyone. So the link, they should have the link to this presentation, but I will add it to the document as well.
Yeah, just so that when they go back in there and going through it, they see, you know, they remember, we remember where this link is.
Yeah, I'll add it to the document. Any other questions or suggestions for today? Any of you having trouble with local Git flows? I think Dr. Nelson, you had mentioned that someone had pulled a GitHub repo and there were issues that were happening locally.
Anna, does this help answer your questions?
Yeah, it definitely helps out a lot for trying to figure things out.
Okay. Cool.
Hey, Rohit, this is kind of a trivial question, but how do you get on your terminal, how do you get the lines to separate your blocks of commands?
What do you mean?
Like on your terminal, you have like a set of
this like
break. Yeah.
Oh, so this is not really important or part of the course, but every terminal has a bash RC file or a bash.profile file, and you can make a lot of changes in here. So for example, the color scheme that you see in my terminal, or if you would notice that sometimes I'll type GS and that runs git status instead of, because GS is not really a terminal command, it's just my alias. So I can set up aliases in here. I can do a lot of other things. But one of the things I can do is do this, which basically says that anytime there's a fresh command being run, it will just add these two lines in my terminal. Oh. So it's a simple, stupid hack. It's not really anything super fun, but yeah, with your bash profile, you can do a bunch of things to your terminal. And yeah, so like I prefer using the trash command instead of remove RF because trash actually takes it to the trash, your trash bin, like at least over here. It copies it to the trash directory basically. Instead of remove RF, will delete it permanently from your system, and there's no very easy way to recover it. Like there are very difficult techniques to recover it. But yeah, that's kind of also what happens when you install Tethys, right? Like it adds this line to your bash profile. And that's why when you are in your terminal and you do T, it actually starts up the Tethys environment, and that's because it runs this command. But yeah, so it's basically just some little trickery on your bash profile.
Gotcha. Cool. Thanks.
Yeah. Yeah, aliases are super helpful. Like I wouldn't live without these for my work. Like it makes life so much easier. Yeah. Any other questions? Otherwise, I'll work on that video sometime this week. And if you guys do have any questions about GitHub, or if you get into areas in GitHub where it's like you're doing lots of merges and you're having conflicts and don't know how to resolve those, hit me up on Slack and we can work through together. A lot of times I've seen people when they run into conflicts or merges, they'll just copy their changes to a different directory delete the GitHub repo and redo the changes, which works, but it doesn't really help you get better at Git. So yeah, let me know if you have any good questions or any concerns about Git. Yeah, that's all I got.
Great job. Thanks, Rohit.
Okay. Thanks, Rohit. Yeah, you should all have access to those slides. We will disconnect and talk to you all later.